Okay, so this is 129 sum root to leaf numbers. If you've already seen the other problem, path sum 2, this one looks remarkably similar. It's another depth first search problem. And here's how it goes. So you're given the root of a binary tree containing digits from 0 to 9 only. Each root to leaf path in the tree represents a number. For example, the root to leaf path 123 represents the number 123. Return the sum total of all root to leaf numbers. A leaf node is a node with no children. So they tell you, okay, you're given 1, 2, 3, the output is 25 because this is actually 12 plus 13 equals 25. And here, 495 plus 491 plus 40 equals 1026. Okay, so that's what you need to do. We're going to do it the same way, and in fact what we were doing the last time on path sum was pre-order, not in order, as I knew I got that wrong. But it doesn't actually matter what you call it, as long as you traverse down the tree as far down as you could go. Every time you hit a leaf, you add the current number that you've been accumulating as you've been getting these digits to my return, which is how we're going to do it. So, okay, so if root equals null, that's our little sanity check, return 0. So that does nothing. Otherwise, int my return equals 0. So it's important to initialize to 0. Otherwise, depending on your compiler, it might not work well. And that's the case for LeetCode. So return my return. This being the universal constructor there. So, okay, now we're going to throw in pre-order, and we're going to throw in the root. We're going to throw in, what is it, my return. We're going to throw in the current sum, which is, yeah, we're going to throw in the current sum, and I actually think that's it. So let's build this thing. Void pre-order. We want to throw in the int my return. Oh wait, but before we do that, we're going to throw in the tree node root. We're going to throw in the int my return, which is passed by reference, as well as the int current number, which is the one that we're accumulating every time. Oh, I forgot a comma. That's why it wasn't doing the indentation properly. Okay, so the first thing, let's just kind of air this out a little. Okay, so if root equals null, then we return. Otherwise, okay, so here's where the magic happens. First current number. So now we have a number to play with, equals current number times 10, and this is how we're going to do that, plus root.val. Okay, so this is how we're going to increment the numbers. So if we already saw 1, we do times 10, that's 10, plus 2, and that gives 12. That's our current number. Now, what happens if this is a leaf node? And to check if it's a leaf node, we say, okay, if root.left equals null and root.right equals null, and isn't that a cool C++11 syntax? My return plus equals, so we know we have to add up our current number, and then we could return. Otherwise, we could just be on our way towards the left. That's how we're going to iterate. And we're going to throw in my return again, and we're going to throw in current number. We're going to do the same thing for the right. And we'll pray to all the various gods that it works. And our survey says yes. We hit submit. Ho ho! 100% all over the place. And we have a winner. See you later, everyone. Thanks for watching.